On a clear night, the universe looks like a frozen tapestry of stars. But if we accelerate the clock, that stillness disappears. Every object in the sky is actually moving in a massive, high-speed vortex. On Earth, movement requires an initiator, a kick, a push, or an engine. But space is a frictionless vacuum. There are no external forces to get things moving, and nothing to slow them down. This creates a structural problem. Left to gravity alone, the early universe should have collapsed inward. Without an organizing force, every particle of gas and dust would have fallen straight toward the center, crushing the cosmos into a single, unstable pile of matter. To understand why that collapse never happened, we have to look at the state of the universe shortly after its birth. It began as a vast cloud of primordial gas that was almost, but not perfectly, uniform. Within that cloud, there were microscopic deviations in density. These tiny irregularities acted like angled strokes in a swimming pool, creating the first uneven gravitational pulls between gas particles. These pulls triggered the law of conservation of angular momentum. Instead of colliding head-on, particles began to slide past each other, turning straight-line gravity into circular movement. Because space has no friction to act as a brake, that initial energy couldn't dissipate. As gravity compressed the gas, the rotation accelerated, locking the cloud into a permanent spinning vortex. The rotation we see today is the stored kinetic memory of that birth. But raw, chaotic spin isn't enough to build a universe. The cosmos still needed a way to turn that swirling gas into organized structures. As a gas cloud collapses, gravity pulls matter toward the center, while centrifugal force resists it along the rotation plane. This conflict flattens the cloud into an accretion disk, nature's sorting facility, organizing matter into distinct concentric bands. By flattening into a disk, particles are forced into the same orbital trajectories. This allows them to gently collide, heat up through friction, and eventually fuse into larger bodies. Without this specific architecture, matter would either scatter into the void or form unstable heaps. Rotation creates the manufacturing pipeline that turns cosmic dust into stars and planets. On a larger scale, we see entire galaxies, collections of hundreds of billions of stars spinning through the void at hundreds of kilometers per second. This creates a mechanical puzzle. Calculating the mass of every visible star and gas cloud, there isn't nearly enough gravity to hold a galaxy together at these speeds. By standard physics, stars at the outer edges move so fast they should have been flung out into deep space billions of years ago. This is where dark matter enters the picture. It acts as an invisible scaffold, providing the extra gravitational weight necessary to keep the spinning system intact. The interplay between this rotation and dark matter acts like a cosmic gyroscope. It confers a structural rigidity that allows galaxies to exist as stable, cohesive organisms for billions of years. What happens when we look at the densest limits of this rotational law? We see neutron stars, objects with the mass of our sun crushed into the size of a small city. As these stars collapse, their spin accelerates until they are completing hundreds of rotations every second. At this speed and density, the star becomes a pulsar. Albert Einstein's work on general relativity suggests that a mass this dense doesn't just rotate within space. This is the lens-theoring effect. The pulsar is so massive and spinning so quickly that it literally drags the fabric of space-time along with it, twisting the geometry of the universe into a spiral. At these extremes, rotation is no longer just moving matter around. It is actively warping the fundamental structure of reality. Back on our own scale, Earth's predictable orbit is a direct inheritance of the momentum from that early solar accretion disk. That orbit keeps us at a distance, but it doesn't protect us from the sun itself, which blasts the solar system with radiation capable of stripping away our atmosphere. Our defense is a hidden internal mechanism. Deep inside the planet, a core of liquid iron and nickel is constantly spinning, functioning as a geological dynamo. This internal rotation generates a magnetic shield that deflects the solar wind. Without this constant movement beneath our feet, the atmosphere would have been swept into space long ago. From the spiral of a galaxy to the liquid metal in our core, rotation is nature's most reliable engineering mechanism. It has operated without interruption for billions of years. Modern astronomy continues to track these rotational forces to understand the balance required for a stable solar system. When we look at the stars, we see the structural result of a process that began with microscopic deviations in gas and led to the creation of everything we know. Rotation provided the stability for matter to eventually become us.